Hello everybody. I hope you can hear me. My name is Eugene Rausch and I will present you a new product which is called ActiveIcmJS. And so I will start with some PowerPoint slides which shows the technology and background behind that product. Then I will switch to some live demo which shows how to create pages which contains ActiveIcmJS, and then I'll switch back to PowerPoint for conclusion, and in the end I will answer some questions. Produced in 2009. It was native code built using a special API provided by major browsers, all major browsers, and it allows you to embed some 3D scenes and 3D molecular data inside the web page. And it was quite popular because people can easily share and publish their data on the web pages and access it all around. But in early 2015, situation changed because Google announced that native plugins, they're going to drop support for native plugins because of security and compatibility issues. And other browsers starting to follow that fashion, so the plugins are going away. So we're starting to look for possible alternative to how people can exchange and publish molecular data on the web pages. And fortunately, we found a good alternative, which is called now ActiveIcmJS. So JS means JavaScript. So the JavaScript is a standard language for web pages. So currently all web pages consist of some sort of JavaScript code. So we port our ICM shell, so our desktop product, which is mostly consists of ICM shell with hundreds of functions and scripting language, and 3D graphics module. So we port that into JavaScript. So the code is compatible with all modern browsers because all modern browsers can support JavaScript. Does not require any additional installation because JavaScript is enabled and all browser contains it. It has the most important thing. It has a full access to ICM scripting functionality through JavaScript object, which is exported into HTML page. This is a key feature. So it's not just a viewer which you can rotate or manipulate on the web page, but inside it has a full functionality of the ICM scripting language. It is mobile device friendly, which is quite important nowadays. The other important feature is the same graphics quality as our desktop application. We managed to maintain the same code base, so all the representation you used to see in our desktop applications will look the same in this HTML page. And the other key feature is near native speed. I will show you some benchmarks, but we managed to achieve the same speed as a native desktop application, or near native speed. Is a little bit slower, but not significantly. So let's talk briefly about technology behind ActiveICM. So we use so-called ActiveIcmJS, which is special low-level subset of JavaScript, which was introduced by Mozilla Foundation some time ago, and now all browsers support it. Because it's very strictly typed and low level, so browser can run it at almost the near native speed. So the slowdown is from 1.5 to 3 times slower than a native code, which is very important. So you basically can run even minimization and energy calculation, and I will show you some benchmarks inside the browser. So that's a really cool feature, and it's really important. So obviously you cannot write this sort of ASM.js by hand, so there are special tools which allows you to compile C code or C++ code into that ASM.js. So some statistics. So we managed to compile about 350K of C++ code. It's basically all the shell language, all the functions, and everything which we have, plus 3D module. So everything excluding GUI. And the result JavaScript library is 18 megabytes, which is it's for full ICM and about 14 for lighter version, which excludes some energy calculation and minimization. And the compressed size is like 4.7 megs or 4 megs for light version. So basically it's quite a big library, but it's manageable. Nowadays the internet speed is quite good. So it's but again, it brings you all the functionality of the desktop product inside the browser. So the real challenge was to port 3D graphics into browser page. So browsers support so-called WebGL, which is a very limited subset of OpenGL. And as I mentioned before, we want to keep the same graphics quality and the same representations as we have in our desktop applications. For that, we need to keep the same code base. So we have some rendering code in C++ or C, and we want to keep the same code to produce the scene in a web page. So for that, we developed a special layer which translates missing functions from WebGL, from OpenGL into WebGL. So this allows us to keep the same code base and deliver the highest quality graphics to the web page. So basically everything which we have in desktop application, almost everything. There are some limitations, but like 19% of the what we have in desktop now are available in a web page through the JavaScript and WebGL. So here are some examples about how the simplest possible page which contains ActiveIcmJS object will look like. So as you can see here on the left side, it's a neat set of HTML code. So it contains, the first line contains just standard inclusion of the JavaScript library. So that's basically all you need to enable ActiveIcmJS in your web page. Then you have some standard div element, which is a sort of container or where you want to put your object. It can be anywhere in your page, so you need just some parent HTML container. And next, there is a function, there is a callback. So because the JavaScript library is quite big, it loads it in a asynchronous fashion, so you need to have some callback when the library is loaded. So the callback is default name for the callback is onload ActiveICM, where you can just create your ActiveICM object, providing the name of the parent container, and then you just specify the project. Project can be either ICB file, URL to ICB file. So if you don't have any path, that means that it should be relatively in the same directory as the main HTML. Or it can be PDB code. If you don't, the PDB code, it goes into standard PDB website, or it mirror and loads the PDB by the code. So if there is four-letter abbreviation for project file, it will load the PDB file. And this small piece of HTML code will produce the picture on the right. So it will load our default representation for the protein, where ligand is X stick and protein is ribbon. Coloring is M2C, and there are some site residues with Xfix. So this is a pretty, basically for those who are familiar with our desktop products, that's what you have when you load PDB into desktop. Another key feature which I mentioned is ICM shell, ICM script integration. So here is the example how you can access ICM shell from the JavaScript. So on the left side again you have your ActiveIcmJS object. You can load some predefined set of macros, for example here, or you can load your own macros. And you can run any ICM command. For example, below there are two commands which will display the ligand with CPK and display neighboring pocket residues with a Xstick. So you see it's pretty simple, two commands, and you will have the picture like on the right side. And so ICM shell provides the very flexible language for manipulating with various representation and molecules, and so the full access is available from the JavaScript. So everything you can do with desktop ICM you can basically perform here through the HTML page. And you can have multiple ActiveIcmJS objects on the same page, and even more, you can link them for synchronous syncrotation. So for example, if you have two different ligands in the same pocket, there are some modes where you want to rotate them simultaneously, and in that you can just add them to the same group. So there is an add to group method on this JavaScript code. And after that, you can rotate both of the one of these images or objects, and the rotation will be automatically synchronized with the second one. Some additional features for the ActiveIcmJS object is the PDB search, flexible interactive PDB search. I will demo that. It allows you to search by basically all keywords that contains in PDB index. Also, there is a nice sequence view in the bottom, which for those who are familiar with our IMOView application, which is mobile version. So it's similar to IMOView. So you can select something here, and the selection will be reflected in 3D view, and vice versa. So you can select in 3D, and the selection will be shown in a sequence view. You can center on selection, and so the rotation will be around that selection. And I will mention later that in the development version we already have some GUI, so it allows you to color selection, toggle different representations, and do many other things. Full screen mode support, which is a really nice feature. So you can toggle your ActiveIcmJS to occupy the full screen, and touch and multi-touch. For devices which support multi-touch, you can this two-finger zoom, two-finger rotation, all these gestures are supported. So this is just two screenshots for mobile, how it looks on the mobile. So for those people who've been using our old ActiveICM, the question is how do we port or translate our old web page into the new one. So there are basically two modes, and I will demo one of them later. But briefly, so the popular scheme to export your molecular document. So molecular document, we introduced it again in 2009. So it basically consists of 3D scene on the right and some HTML annotation with active links on the left. So this is a quite popular format, and people use it a lot. So these active links usually toggle some representation or slide in the right side. So if you have such ICB file, you can just re-export it into new mode. You see this export graphics in WebGL, and that will create a new page with already ActiveIcmJS enabled. And this is going to be a work as an old ActiveICM, so you will not notice any difference. For manually created pages, you can perform some simple operations like shown on that slide. So, for example, you can translate this, replace this object tag with the code below. So basically, all you need is to replace a few HTML lines, and the API is the same. So basically, your page will work as before. So all these run commands and all methods, all the ActiveIcmJS objects are compatible with the old ActiveICM pages, ActiveICM objects. Now I would like to show you some benchmarks which I performed to show you how the really heavy computational stuff behaves in this ActiveIcmJS object. So there are several tests I performed. So first is a conversion of, it should say convert 2D to 3D. It's a typo here. It's conversion from 2D to 3D. It's our standard operation, which we perform some minimization of the geometry in MMFF terms and produce 3D ligands. And another set is convert to object. It's our also standard operation in desktop applications, which takes the PDB object, converts it into ICM, optimize hydrogen, and performs some other housekeeping operations. It's quite heavy operation, as you probably know. So on average, it may take a few seconds on average PDB. And another popular task is ICM Pocket Finder, which finds the possible pockets for docking and for ligand bindings in your PDB. On that slide, you will see blue is Chrome, red is Firefox, and green is a native code, which I perform on the same machine. So on the machine is specification is here. So as you can see that most of the operations, almost all of them are. So there are less than 2 times difference between Firefox, for example, and the native code. And Chrome is also performing quite good. It's around 2 times, maybe a little bit more, 2 times slowdown comparing to the native code, which is quite amazing and very promising. Some other tests which comparing Microsoft Edge, Chrome, and Firefox on the same operations. Actually, it was a big surprise for me that Microsoft Edge, it's a new version of Internet Explorer. It's faster than Chrome, so so they did something really good on that because the previous Internet Explorer was quite slow on JavaScript, but this one Edge is really fast. And you see the Firefox is the leader, which is no surprise because, as I mentioned earlier, this ASM.js was invented by Mozilla, so other browsers just follow this fashion. But again, you can see that this Edge is on the 3rd place, and the Chrome is the last one. But again, it's really good even for Chrome because it's comparing to the native code is very fast. This is a Safari, Mac OS X, and you see that Safari is a little bit, not a little bit, but significantly slower than Chrome and Firefox. I should say that it wasn't really last version of the Mac OS, so it's maybe they did something. They will probably did something so to catch up with other browsers because it's slower than Chrome and Firefox. But Chrome and Firefox, as you can see, the speed is also near native. Okay, now I will switch to some demo. So I will show you the PDB viewer, 2D to 3D conversion, and some exporting demo how to export pages. So for the PDB viewer, so you will probably notice that we have updated our web page. So it's so it shows the new PDB viewer, which is already fully in JavaScript. So this is a selection, and also you can select here, and the selection is translated. You can toggle representations here. You can toggle anaglyph stereo mode. You can change background. But in a development version, there are much more functionality already. So this is sort of already behind a little bit. But I'm showing it because it's our main version. You can search by any keyword here, and you will load your protein. So that's one application where it can be used. And for 3D converter, so we have some 2D ligands, and we convert it to 3D using and display it in ActiveIcmJS. So for the let me switch to the demo. So let me show you how to export your molecular document into new ActiveIcmJS. So I will take an example from Oxford SGC. They produce routinely this sort of molecular document where you have your annotation with some active links, and you want to, for example, export this page as ActiveIcmJS. So you can go into File Export, and then you toggle this. Basically, on my slide it calls WebGL, but now it's more familiar. So it's ActiveIcmJS, and you can also show it in a browser. So it launches Firefox, which will hopefully open our page. Yes, it does. So we can switch to this annotation slides and check some links if they're. As you can see, all this slide transition and everything works as in desktop application. So this is one example, and let me switch quickly to another one. So another popular thing which you can distribute over the web is a docking hit list. For example, if you have standalone docking hit list from docking run, you can also export this as ActiveIcmJS page. So you can basically go to export, say you will see the poses table with the poses on the left side, and you can toggle different poses and see how the table contains everything, so you can basically sort and pick the best pose. You can compare them by clicking multiple poses. So that's another thing you can do with ActiveIcmJS. And let me actually show you some how to create, for example, the new page from scratch. So if we just get rid of everything, let's load some PDB. So let's make some background. Well, let's create slide 1 and call it overall view, smooth transition. Now let's focus on the pocket, on the ligand. Let's rotate like this, toggle CPK, create another slide and call it ligand view, and also enable smooth transition. So now you have your two slides. And so if we export, so you basically don't need anything else. You can just go and say export and then browse, pick some directory and say so now you see you have your two slides on a web page, which are the transition working fine. So everything is, so basically that shows you how you, like in 5 minutes, you can create some simple annotation on your protein and publish it. So that basically very simple and easy. And I did it in this ICB file I prepared in a full ICM, but obviously you can do it in our free browser. It will work the same. Okay, let me switch back to PowerPoint. So let's talk about some limitations which we currently have in that version. So the size, the first thing is the size. As you notice, the loading time is visible. It's few seconds, and that's because the size of the JavaScript library is quite big. So basically, not much we can do in this area without losing major functionality. So obviously I can cut it into like in half, but in that case I will need to drop a lot of scripting and a lot of functionality which we don't want to do. And the reason is because basically when you load the same page multiple times, usually all the browsers will cache your JavaScript library so that the following loads of that page will be much quicker. And for those customers who wants to have this on their server, so we also provide that opportunity, so you can download this JavaScript libraries and host it on your server, which sometimes may be quicker, especially if your audience is on the same, you're using the same network. Another limitation, but not really big, is that read command. So for those who are familiar with ICM scripting language, we have various read commands which allow you to read data from different sources, URLs and stuff like that. So this read command will not work inside if your script is run inside ActiveIcmJS. And the reason is because the browser will not allow synchronous read commands. So for that you will need to split your script in two parts and replace it with a special JavaScript code which we provide and there is documentation on that and examples. So that's basically not a really big limitation. And some other stuff, the animations currently only supported in slide transition. So if you have some script which produce some animation that will not work in ActiveIcmJS mode, but that I can probably fix in the next releases. So that's not should be possible technically. And this next slide demonstrates the future work, which is actually I'm already doing. There is some developer prototype of the GUI interface, which we want to add to this object, to ActiveIcmJS. As you can see in the bottom image, it has the ability to toggle various graphical representations: wire, CPK, XT, ribbon, and surface. And it works either on the whole ligand or on the selection. You can label sites, residues, or atoms. You can toggle full screen from the menu. You can select neighbor atoms. You can measure distances and angles and torsions. There are some tools menu, assign secondary structure, and we will have more stuff. There are various coloring schemes, and the recent stuff I added, so you can actually sync with a Google Drive, and I'll probably add Dropbox. They also provide the API for save and open your projects. You can create slides, and the slides will be saved. And yeah, so basically that's pretty much it for now. This is a developer prototype how the next version will look like, and as you can see, now it's more likely more close to functionality of the for example ICM browser desktop applications. And in the future we'll add some plots and alignments and tables in JavaScript version 2. So basically the idea is to have ICM browser inside the web page. So here are some links, and so the most interesting for people who are interested in technical details is a technical reference link, which actually in details shows the API how to use the ActiveIcmJS object inside your custom web page. So this is a general link. So licensing is it's free for personal non-commercial use if the library is hosted on our site. If you want something more, for example, if you want to host it on your site, or if you want some additional features, you may contact us and we will arrange that. And so that's pretty much it. This is a list of acknowledgements, and so I would like to thank all these people for helping me with developing that product, and I would like to thank the audience for listening. And so if you have any questions, you can type it and I will answer them right now. Thank you.